Calculate the degree of hydrolysis of CH3COOK, that is potassium acetate, in 0.1 m and the pH of the solution. Acid dissociation constant for acetic acid is given as 1.8 into 10 to the power minus 5. This question is very much similar to the previous question. Here you have to find the degree of hydrolysis, and what is given molarity of potassium acetate solution is given, that is 0.1 m, and pH of the solution you have to find out. You have to find out the pH of the solution, and acid dissociation constant for acetic acid is given. Now the equation for the hydrolysis of potassium acetate is potassium acetate plus water forms acetic acid and potassium hydroxide. From the stoichiometry of the equation, it can be seen that 1 mole of potassium acetate hydrolyzes to give 1 mole of acetic acid and 1 mole of potassium hydroxide. If the degree of hydrolysis is H, then H moles of potassium acetate will hydrolyze to give H moles of acetic acid and H moles of potassium hydroxide. So amount of potassium acetate remaining will be 1 minus H. Amount of acetic acid formed will be H, and amount of KOH formed will also be H. This is when the initial concentration is 1 mole per liter, right? But according to the question, the initial concentration is given as 0.1 mole per liter. So multiply all the values by 0.1. So amount of potassium acetate remaining will be 0.1 into 1 minus H. Acetic acid formed is 0.1 H. Potassium hydroxide formed is 0.1 H. Now KH is equal to KW divided by K. Value of KW is 10 to the power minus 14 and K is 1.8 into 10 to the power minus 5. And KH is also equal to concentration of acetic acid multiplied by concentration of KOH divided by concentration of potassium acetate. Amount of water is constant. So putting the values, KW by K is equal to 0.1 H multiplied by 0.1 H divided by 0.1 into 1 minus H, right? Now 1 minus H can be neglected in the denominator. 0.1 and 0.1 gets cancelled. So here 0.1 H square is equal to 10 to the power minus 14 by 1.8 into 10 to the power minus 5. This 10 to the power minus 5 goes to the numerator, and this becomes 10 to the power minus 9 by 1.8. Solving H square will be equal to 0.056 into 10 to the power minus 7. Now value of H will be equal to square root of 56 into 10 to the power minus 10. 0.056 into 10 to the power minus 7 can also be written as 56 into 10 to the power minus 10. Solving value of H is equal to 7.5 into 10 to the power minus 5. This is the approximate value. Now once you know the value of H, amount of KOH present is 0.1 into H. So 0.1 into value of H, this gives the amount of KOH, that is 7.5 into 10 to the power minus 6. POH will be equal to minus log OH minus, which can also be written as log 1 by OH minus, which is equal to log 1 divided by concentration of OH minus, that is 7.5 into 10 to the power minus 6. Now log 1 by 7.5 into 10 to the power minus 6 will be, this 10 to the power minus 6 goes to the numerator, it becomes 10 to the power plus 6. So POH will be log 10 to the power 6 minus log 7.5. Log 10 to the power 6 will be 6 minus log 7.5 is 0.875. Solving POH is equal to 5.125. So pH will be equal to 14 minus 5.125, which is equal to 8.88. pH plus POH is equal to 14. So pH will be equal to 14 minus pOH, and value of pOH is 5.125. Solving pH is equal to 8.88. So degree of hydrolysis is 7.5 into 10 to the power minus 5 and pH is 8.88.